Hello students, in this video we will discuss the classical mechanics by the Tom Kibble and chapter number 8, many body systems. Okay, now we will consider the any material object. Okay, like this is the any material object. Okay, and which is consist of a large number of small particles. This is a large number, but this particle is small. Okay, but this tell lot enough to obey the classical mechanics. Okay, these particles obey the classical mechanics law rather than the quantum mechanics. Okay, then we consider n particles. Okay, n particles, which is label or represented by in the index I is 1, 2, 3 and up to n. Okay, there are n particle which is represented by this. Okay, and then the interaction between the two particles force we consider like this. This is the two interactions between the two particles. Then this interactions is cannot be affected by the other bodies. Okay, according to the superposition principles. We can simplify her. This is like this systems. Okay, here the force is let's say 1, 2. This is particle 1 and this is 2. Okay, and this force is let's say is 1, 3. Then this force is cannot affected by this force. Okay, these forces are completely unaffected by the other bodies, by this forces on this. Okay, then and there is also these are only the externally ones. Okay, only the external force between these two body, and there is also the external force also. Okay, outside this system. Then we donate the force between these two is Fij. Okay, let this one is I and this is J. Okay, and there is also the external force outside this system. There is also other object which is exert a force on this system, and this force is represented by Fi, only this external force. Okay, then the equation of motions is can be written is mi and r double dot, this is accelerations, is equal to Fi1 plus Fi2. This is the force on the ith particle due to the all these particles. Okay, and I3 and up to In and plus the external force outside this system is Fi. Okay, then we can write this force and the summation form is I and I not Ij. Okay, this is J and Fi, and this one is J1, 2, 3. Okay, and then this is the external force Fi. Okay, and there is no force the I and the due to the yourself store. Okay, like I, there is no force. This force is 0. Like 1, 1 F11, there is no force, and so many ones. Okay, then we will discuss the momentums. Okay, what is momentum. And this momentum is discussed in terms of the center of mass motions. Okay, then this is center of mass motions. Okay, now the position R of the center of mass is for the two body systems. Okay, now the position of R of the center of mass is R is equal to m1 r1 plus m2 r2 divided by m1 and plus m2. This is the positions of the center of mass for the two body systems. Okay, now for n particle, the position of the center of mass is can be written as is m1 r1 plus m2 r2 plus m3 r3 and so on, divided by m1 plus m2 and m3 and so on. Okay, this is for the n particle. Then we can write this in the form of summation, and I of mi ri and divide by the summations of I of the mass. Okay, the mi, sum of the mi. Okay, and here the summations of the mi is equal to the its total mass, because this is the sum of the all particle mass, and this is equal to the total mass of the systems. Okay, then we can write these equations. R is equal to 1 over m and the summation of mi ri I here. Okay, then the total momentum for this system is the total momentum is phi is equal to the sum of the all the particle mass and its speed. Okay, then we can write this, and also this is the total mass and its position with respect to RT. Okay, this is the velocity. Now then this is equal to the momentum of particle is the total mass at the location of the center of mass. Okay, then the rate of change, the rate of change of momentum is, we know the mi and r double dot I is equal to the sum of the m, or not m, this is the Fij plus the external force. We already derived this here. Let us look here, this force. Okay, then we can write this equation like this: d divided by dt into mi and r 1 dot, here 2 and this is 1 dot, the one derivative is take common, and then is equal to j, the summation of j f of j plus the external force. Okay, Then this is the momentums. Okay, so here t divided by dt, and here we write the summations and term of I in mi or dot I, and here also, okay, this is the I summation here and also here, and Fij plus the summation I and Fi. Okay, then this is the total momentum. Okay, the total momentum of a system, then the d divided by dt is, this is the momentum. Fi is equal to the sum of the summation of the force Fij and plus and the summations of the Fi. Okay, then this is the total momentum, and this is represented by the v dots. Okay, this is the change in momentum. This is the first time derivative of momentum. Okay, and this is equal to the summation of the Fij plus the summation of I and Fi. Okay, then this two body system must obey the Newton third law. Okay, the Newton third law which is stated Fij is equal to the minus of the Ji. Okay, and this is there is equal but opposite term. Okay, these two magnitudes are equal but only the negatives. Okay, now there the change in the momentum and this. Okay, now it can be written as the term and the double summations is cancel each other according to this Newton third law. Okay, because if we consider the I is 1 and the j is 2, then this is equal to the minus of the 2 1 according to this one. Okay, and now we consider the I is 2 and the j is 1, and then according to this one is, this is 1 2, so these two are cancelled, this and this two cancel, and so on. So this term is become cancelled, and there is no change due to the internal force. These are the internal force. Okay, so there is no change in the momentum. Then we can write these equations. The change in the momentum is equal to the sum of the Fi, and this is the only the external force which change the momentum of systems. Okay, then we consider for isolated system, there is no external force on the systems. Okay, when the external force is 0, okay, for the isolated system, all the external force is 0. The sum of all the external force on the system is 0. Okay, then this equation can be written as the change in the momentum is 0, and the change in the momentum, and we can write like this, as 0. Then we can write here the t, this is not dot. Okay, the dp is equal to 0. Then we integrate both sides, and this is p and this is constants. Okay, then it will give the law of conservation of momentums. Okay, the isolated system, this give the law of conservation of the momentums. Okay, and this is also equal to the m or third is constants. The momentum of the total system is constants. Okay, then now we consider the composites body. Okay, the composite body. If the this body is isolated, okay, if the body is isolated, then according to the first law, this means that there is no external force. All the external force, we can draw this is a systems, okay. All the external force on this system is zero, okay. Then according to the first law, it's move with the uniform velocities, okay. So this law is maintained for the first Newton law, or obey this law, okay. This is according to the first law, okay. And then this is a first law, okay, the Newton first law. If there is no external force, then the earth will move with the uniform velocities, okay, and let's obey these systems. And now according to the Newton's second law, and this is second law, state that the change in the momentum is the sum of the external forces, okay. The sum of the external force on all of the earth's constituent particles, okay. There is so many particles, okay. There is the sum of all the external forces, okay. And the mass is the sum of their masses, okay. And their mass, its mass is the sum of their masses, small masses, m1, m2, and so on, okay. So then it's will fly to the body as a whole and also to the point particles, okay. Now according to the Newton third law, which is apply to the each pair of particle from the two composite bodies, okay. For the Newton third law, there have at least two bodies, okay. There are two composite bodies, so this also obey this law, the third law for the composite bodies, okay.